So bringing back to one of the things that Ellen talked about, which is passwords, identifying who you are. I mean, in general, it's not a bad idea if you just had to remember one password and nobody knew about it, right? I mean, just like it would be pretty cool to just know one password in your head that you could change pretty often. There are characteristics of a password, something you know. It really falls under something you know, which is really good if you interacted with a very, very small subset of things that care about it. Because you could honestly change it very quickly if something happened. The problem is that we ask everyone to remember tons of them and that they're all different. That's where the problem is. And not only that, because you can't do that, so you start to basically use the same one everywhere. And then it takes two to know and verify that, right? So you have to trust somebody. But if the somebody doesn't do a good job protecting what that secret is going to be, chaos happens, which is where we are today. So I like I'm sure most of you are familiar with this password slide, which is really cool. And the key element here is that we tell our users to remember these complicated things, which is actually pretty hard for the users to remember, but it's actually very trivial for the computers to replace the exclamation with the one exclamation. Who does that, right? A 0 with an O. Like, I mean, that's trivial for a program to do that if you sort of, ask people to do things like that. So we got to stop, right? And it's not just technology. I'll be really transparent. I mean, this is about the user journey. The user journey has to change. And if I told you everybody could go like passwordless today, I would say half of you, or probably more, I will probably take a guess, who don't really understand what that means. Was at a conference not too long ago, and I said, you could get this journey of passwordless. And the first question was, so what happens if I forgot my password? I just said, you go passwordless. So there's a journey that we need to think through what that means. I'm going to talk a slightly different angle from what Mark talked about. I'm going to talk about some of the threats that we see today that are evolving. So we talk about technology innovation. I'm going to tell you about what the threats are evolving today, which is so easy, and you need to be aware of. Because at some level, your organization and your companies need to address these things because they directly impact the user journey and they obviously impact fraud. So this is nothing sensational, I would say. Most of you should be familiar with this sort of stats. But in essence, we know the challenges with passwords. But the number one reason is that they get reused and that you can actually phish these credentials pretty easily at scale. And I'll talk about that in the next couple of slides. Now, we've tried a whole bunch of things in industry over the last, I'd say, 10 years or so. As Mark pointed out, there's a bit more innovation going on in Europe stuff aside. We didn't use some of these techniques. But in essence, it's either still pretty complicated for the user, which is a lot of friction, and that sort of you tie things to things that are really hard for the infrastructure to scale. And what I mean by that is that sometimes you are going to a site and it's great, it's very easy, using your passwords, it gets you in and you can do a transaction. But sometimes it's like you've got to download this application, install this extension, do all these songs, singing and dancing just to get to a point where you can make a transaction or you can get authenticated. So when you introduce friction to the process of doing whatever the customer wants and the user wants to buy something and you prevent that, they're just going to find ways around it, right? And worst of all, a lot of techniques used today involve some type of element where you could trick the user to give you the information that the attacker could use. So I'll do quite a basic phishing 101, which is where baseline. This is what's happening in the industry. I mean, if you're not convinced, you can just type in various key elements of what is happening in the industry today or what we're seeing today at scale. So I'll go through a very simple example. Any legitimate attachment can be a way to phish the user, right? So you think about scale. This is not exciting invoice if it's to, say, your HR. It would be very exciting if you are payroll. If you change the attachment to like excellent resume candidate for blah, 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 now HR is going to be interested. So any legitimate link can be turned into something that they usually want to click. I mean, people are just curious. You cannot, no amount of training, I guarantee you, can prevent curiosity, right? So this is going to happen. So what happens after you manage to phish the user to go click on something, which is very common? Things like that are common. Whether it be, I'm not dissing Google or anything like that, but this is pretty common. You get a set of like, hey, it looks like Google, it looks like, name your favorite service, Facebook or whatever. You just name your favorite service, social media site that you are using to get on as your identity. So we know about social logins, right? Use Facebook to log in, use what? And in fact now, a couple of these things are also happening in other parts of the world. Use something else to log in. And interestingly enough, this is a fake Google site. So any good site can be turned to a very simple fake site. Again, these are all rendered over the web. So if you don't really know what's behind the scenes, you're just going to believe that I'm going to do this. Interestingly, it's kind of hard to see here, the last screen here shows, hey, actually, I'm not sure. It seems like something fishy is happening. So the fake site is saying something fishy is happening. And please confirm your phone number. This is very common. And by the way, I see that you logged in, but you need to verify your password again. So again, any type of scenario where you are going to ask the user to do something which is legitimate can be turned around. Obviously in the US, we just had our tax time. You can imagine IRS, you haven't paid, pay a penalty now, click here to avoid it. Things like that. This is going to happen all the time. So a quick anatomy of how things work in the background. I want to give you a quick summary on this thing. So you saw a couple of slides on how I can just trick the user to phish. I'm sure everybody knows this. And so you get to the fake site. You put everything you believe was the real site onto the website. It's the bad attacker's website. And basically, they use everything that you've thrown at the good site the attacker can use and log in. And then you, thinking you are logging onto the real site, was a bad site, and you logged into the fake website successfully. And we see this at scale, and this is very standard attack. And this doesn't just mean it's phishing. It can be many ways that attackers go about injecting the username and passwords to sites we call credential stuffing, which is just throw a bunch of passwords and usernames onto one site, and you're bound to hit something. Because the most common password is password. So you're going to hit something. But interestingly enough, so we all know this challenge. Interestingly enough, this attack also evolves around things that some of the new techniques for step up has been around as well. So same attack, but now I protect it with like step up SMS, for example, or one-time passcode to my email or something like that. Let me replay the same scenario here. So the user gets in, puts everything in. So same as before. When the user now puts, the attacker now puts the username and password, it kicks off the system to say, hey, now you need to put in this additional piece of information that I'm going to send you, user. So in this case, it kicks off the SMS or the push or whatever you want to call it, and tells the user, hey, actually, you actually have this second factor thing that you're supposed to do to get in. And in this scenario, the user doesn't know that he wasn't the one that initiated the transaction. It was the attacker. So in his mind, he's supposed to put in the codes into the fake website again. And lo and behold, the attacker just takes the next set of things that the user enters again and logs into the Pharaoh's website, whereas the user thinks that he's really safe because he put in the username and password and he got the OTP codes and he put it in again, but still gets the fake website. Right, so this actually is also happening at scale. This is not a difficult attack. I don't really want to say that SMS is not an option, but I would say it's really a bad idea if you attach your identity to a phone number. Just think of that for a moment. If I know where you live, if I know where you have done business, I would have your phone number. It's not that difficult to do something bad with it. And we still do use these techniques today at scale, particularly in the US. And that's why I'll talk a little bit about what we're gonna need to do. Now, this is another area, this is at scale attacks that we've seen today. SIM-swap, who's familiar with SIM-swap? So SIM-swap, for a sort of a quick education, is that it's a voice phishing, which is I just trick the carrier to say that I lost my phone and I need to put me as a user to a new phone number. Why? Because I've attached my step-up authentication to the phone number. So another bad reason to attach a phone number to a user. The recent attack was actually happening, it's actually happening all over the world. It's not just the US. So the big attacks in South Africa, which happened at scale, there was something in Australia. But this is very easy. You just trick the customer support person at the carrier to change the phone number that is assigned to your account. Customer support, what's the job? Close tickets, make customer happy. That's their job. The job is not to say, hey, I noticed something weird happening and why are you asking me all these questions? And by the way, most of the questions that the user needs to, or the attacker needs to present to the customer support is something you can find on the Facebook account. That's just basically what it is. So the attack is purely social engineering, right? You are using a phone number, convincing the customer support person at the carrier to say, hey, you know what, I really need to change my phone number because blah, 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 give you your saddest story ever. And then the new phone number is attached to attacker's phone, and you do basically everything that you need to do, because as seen in the previous example, now even easier when you authenticate to the site, you just need username, and the two-factor authentication is routed to your phone, and you're done, right? So this is one of the things I bring back was that the need for strong authentication is everywhere. One of the recent attacks that this happened was in the cryptocurrency space. Someone lost a couple $1 million of cryptocurrency because of this attack. Because the cryptocurrency implemented step-up authentication and the only option available was SMS. So these attacks are not going to go away. These are here to stay. And so we need to change the way we think about authentication. A quick education on why this is an important slide was that we lived in a world where what we call shared secrets. I know something, the site knows something, or the organization or the business knows something, and between both sides, I can verify the secret. We've been living this in the past world as well, but it's no different if you have services ask you what we call knowledge-based questions, which is something you remember you know, and again, all the knowledge-based questions can be found on your Twitter feed maybe, or your Facebook feed. This is where we are today at scale. Shared secrets everywhere. What we want to get to is a point where we use public key cryptography. It's a simple way. It's a cryptographic handshake that no one party can kind of review the secret unless both parties sort of work together. So if the public keys on the server are stolen, the bad guys cannot use that to figure out who the users are. That concept is very important. And the reason for that is that we've actually had this technology around for a long time. Who's familiar with the DoD CAD cards? Or the smart cards, these are being used in the security space for a long time. They use public key cryptography, but it's always in this very highly restrictive, highly controlled environment. In order to solve this for the masses, we need to bring this technology and this protocol to the masses, to everyone that can use it on the web. So that's where we want to talk about this. We talk about FIDO, I didn't talk about FIDO, we talk about W3C WebAuthn. I'll give a quick summary. So there are different pieces of the puzzle. When we at Yubico, we worked really heavily with Google in the early days to introduce this technology. It actually was solving an internal use case. And they said, we want the best security, but we don't really like the way that smart cards are panning out. It's just too much infrastructure to manage. And so we had to think of something new. But the elements are pretty clear. There's an authenticator. In this case, it's external authenticator. There's a client platform, and then there's a service or a business. Now, all these components work together to create what we call the FIDO authentication experience. The thing that we recently done is to standardize how clients, for example, a browser or a native application or a operating system, communicate over the web to the business servers. That's what we standardize. It's called web authentication. And I'll run through that a little bit in the next couple sized. The key element here is that what we want to solve user authentication at scale, and we want to provide various options for use cases to be solved. Whether it's second factor, whether it's what we call single factor, or whether it's multi-factor, and we want it to be seamless. One of the principles of this journey for us is to meet key areas that we have seen problematic in the space of trying to authenticate the users to know who their identities are. First, we talk about public key crypto. I just gave you a quick, I guess, less than a minute lesson on that one. Origin checking, I'll talk that in the next slide, which is a very critical element in this new modern authentication standard, because we actually want to know how and where the user is going to do the authentication. I'll talk about that. It's a very critical step for step 2. Principle number 3 is we want the user to have some friction, as Mark was talking about, not no friction. Now, we can have no friction, but again, then sometimes you just don't know really what's happening. One of the things that we notice over a period of time is that when you get so used to nothing, you really don't know whether things are working or whether you're safe or you're not safe. We want to just introduce enough of friction so that it seems natural but necessary, right? So user presence, using things like touch, fingerprint, scans, just enough friction to know that, hey, I'm taking a picture or I'm going to do this, do you want it? And that single gesture is enough to move forward. Rather than, oh, by the way, wait for your SMS to be received, make sure you type in the 6 numbers correctly, but you've got 15 seconds to do it. That is not what we want to introduce into the ecosystem. Another key principle is privacy. While we do authentication at scale, we need to think of identities at scale. And there are many circumstances where you want to know your customer, KYC, but in many situations, actually, you should not want to know your customer for good reasons. We work with different organizations on the other end of the spectrum, imagine journalists and their sources, which want to provide you, you want to know you got that in a very accurate way, but you don't need to review the identities. So the protocol needs to work both ways. We take it seriously, which is when you associate the credential to a business, that is unique relationship between the authenticator and the business. If you associate the credential to the next business, both businesses do not know that it was you. That can be achieved in the protocol. Step 5 is a very important one. We talk about user friction, user journey. And any organization, if you have to call someone to help you, is not just expensive, but it's really friction for the user, right? So the protocol allows for a high level of assurance to maintain self-service, right? Because I think we are thinking of the model whereby I issue you a credit card and that's it. If you lose it, make it super difficult, I'm gonna send you another card and it takes 3 days and this is what you gotta use, or some element of that perspective. What we wanna achieve in this protocol is that you can actually use different credit cards to pay with the same scenario for different banks. So like that mental model, obviously it's not exactly like that, but we want to be able to say you can use an external authenticator like a Yubico, or you can just use your phone, or you can use your laptop. And by the way, don't have more than one. So we built into the protocol a way to quickly add additional authenticators, very little friction, maintain a high level of assurance. And lastly, one of the most critical pieces, we couldn't make this whole thing work if we don't have native support. Now, most of you will be surprised that we talked about this standard. This standard is shipping today. This is being implemented today at scale. Everybody who bought a new Mac with the latest Chrome installed can use this technology. Everybody who bought a new Android phone today has this built in. If it's a business, if you have Windows 10 systems, it's all there. Now, what it should work in the way that we think about this thing is that when you get to the good side, the techniques used is a challenge response technique whereby the browser or the operating system can actually include the origin to the authenticator, and so that when you respond back, you sign it with what we call the private key on your authenticator. Why this allows you to do, again, there's no shared secret here. Using public key cryptography, the service can actually check that this authenticator was tied to this user that you've registered before. So in this flow, you can see that it's sort of a two-way flow. Send something back, sign it, making sure, we've done all these things with like your lawyers for signing buying a house and stuff, you got to sign by all the parties. So we can do that digitally, all seamlessly, and every party can be assured that the final signature allows you to be able to successfully log in. Now, what happens if you do it and there's a man-in-the-middle attack? Notice here, instead of going to the good site, Google, it's Google with the double O zeros. What happens is that if the user was tricked to go to the fake website, that origin of the fake website is part of the signature. And immediately the authenticator says, I never even registered this credential with this site, first of all. And if somehow you still manage to convince and trick the user to go sign something that he's not supposed to be signing, the backend services can say, hey, you know what, this is really not from me. It's really not from my bank or from my, whatever my email service provider is, because as part of the verification process, I can check that this was not the origin. This goes back to the phishing problem that we talked about, is that all this happens in the background. The protocol takes care of everything. And so as a user, you don't need to go read, oh, is this like, looks like Google but not looks like Google? Does this look like a fake site? I don't care. Computers are good at verifying it on the back end. Let them do the heavy lifting. So, many times we work on standards, many times we work on sort of innovation, and we have no policy and regulation to support the work. The good news is that we started this journey sort of like 4 years ago, while including policymakers, including regulators. So there are a couple of things already progressing pretty heavily. Can't really see it here, but essentially this is to the FFIEC, recommend new authentication standards as part of how financial institutions should evolve phishing-resisting technologies, phishing-resistant. And it specifically calls out FIDO, and obviously calls out things related to what we've done in the standard, because phishing was specifically named as the easiest way to get banking fraud. That's basically it. I mean, phishing credentials are at scale, phone or otherwise, or online. It's a huge challenge for everyone, actually, not just the banks, but the users are fall in the same trap. We can assume that while the big financial institutions have a lot of the risk engine to take care of it, many of the small ones don't. As a user, you use both. So you can't, how can small players have the same type of protections as the larger ones if there's no even playing field? People are so good at spending money on reactive defenses, that they think that what we want to say is that let the proactive defenses come up to speed as well. You're going to invest in the best alarms for your house is great, but are you saying open the front door and let everybody in? Which is good if you have the good alarm systems, but not everybody can afford the good alarm system. So why don't we just close the door, have a better lock, so that it's harder to come in. Big update here. I mean, obviously this, for those who are following the policy side as well, this has also updated the Nist Guidance on how they think about the FIDO authentication stack and WebAuthn. So with 863-3, we've really improved the notion that this is no longer sitting in like, it's cool to do it. Like, please do it. It's like we've got guidelines coming up from NIST to say these are things that they have vetted out, they worked with industry, or number of us from the standard size to bring this home, right? Because you need three things. You need the standard, you need the policy and the regulators to catch up, and then you need the implementers, which is where we are all here. And sort of a quick summary on where things are happening. You know, the industry has gravitated to all these technologies over a period of time. We've talked about, obviously, passwords still around. They're going to be around for a long time. In US, we're very focused on this OTP thing here, SMS, and all these issuing of tokens and, you know, numbers everywhere. Europe have moved into some smart card areas and things like that. All sort of have pros and cons. Where we want to gravitate towards is like high assurance level and easy to use and easy to deploy. Why? If these are built into your modern operating systems today, and one of the things that we take pride in, we work very closely with Microsoft Teams and the Google Teams to make sure that these are available on their platform, which means that you have an app developer or you're sort of a service provider, you can leverage everything that is built into devices that your users are using. You don't need to tell them to do something different. Obviously, there are penetration issues in some geographic locations where not everything are uniform. But for most part, we talk about if we can cover, right? If we can cover everything Google, Microsoft, and Apple makes, to what large extent we've covered most of our user base. This time last year, a number of folks were all working on WebAuthn. It was very heavily driven by the Google team and the Microsoft team. And you know, Firefox was getting to be a point whereby they are you know, really participating and accelerating. This is the big news for us this year. I would say that with a lot of hard work from a small set of people, this is now a standard. Ratified standard March 4th.
Yes.
I mean, we're really, really excited. I was just talking to Wendy 3 years ago. I said, you know what, we're going to bring this technology and protocol to W3C, and this is where we are. Now, interestingly enough, you've seen WebAuthn and supported from the browsers and all the different technology providers. When we started, it was only Chrome, Google, and then we moved on to Microsoft and Microsoft technology, and we moved on to Firefox. Notice what's on the bottom right of the little thing that looks like a browser that a number of people use on your Mac devices. The milestone for us is that if we didn't bring this to W3C as a formalized web authentication protocol, we will not have participation from Apple. But that's the reality of the situation, because I think every standard needs to be sort of like neutral, protect IPs, and then can move forward. So Safari is not shipping yet, WebAuthn, but they are what they call STP Safari Technology Preview, which is in their beta phase. We anticipate sometime soon. Maybe they're going to announce it at Apple Developer Conference or something like that. We don't know. I'm not from Apple, so we can only hope. But the hope is at a pretty opportunistic level now. We're very happy that they made a lot of headway. Why is this a major milestone? This is a major milestone because we now have a variety of authenticators that you can use. The goal was not necessarily from our perspective. Obviously, Yubico invented a lot of the initial specification, and we invented the YubiKeys to work with the specification. But the goal was that so that there's more participation. We understand that in order for a standard to be widely adopted, you need to give more choices. Choices not just for the users, but choices for businesses to make the decisions. And so today, all these modalities are available with whatever the devices that you have are shipping with. There are only going to be more. So the innovation part is that as we start to see new players coming in, providing new options for what we call user verification, you're going to get scale because the innovation will continue. But what we don't want to do is to redesign all the plumbings, because we've just redesigned the plumbing. So what we don't want to do is that you do your cool, maybe your biometric authentication, and then you do your proprietary thing again in the back end to talk to your backend servers. What we want is that you use web authentication as your baseline foundation, and you build the innovation on top of that. So we believe that with this model, with external authenticators and built-in authenticators, you can get to scale with all kinds of use cases. You can name your favorite use case, how you want to solve it, including what was discussed earlier, which was web payments. Because if the goal was to identify the users and identify the users easily and quickly, using a web authentication standard so that after you authenticate the users, you can make the web payment. That would be really ideal. Because you can use it for doing a web payment transaction, but you could also log into the bank to do other things. Right? It's one and the same, right? That's why we tie the security model of identity very closely with how we authenticate. Because the way to authenticate would provide a very high signal to the service if it was strong, and it was easy. A quick summary on this sort of this journey from a Google perspective. So you say, okay, what's the proof point? What's happened? Why is this so important? We've done the work with Google. This was an internal deployment before we became a standard. And this is like 5 years in the running now. And they save money, reduce support costs, and obviously are safer. So to us, you can say, okay, maybe I'm not Google. But again, the technology they implemented is now available. So at some element, we should take some of these case studies and learn and sort of evolve. Now, I just want to do, how much time do I have?
You got actually 10 minutes. I mean, we are going to, it's already more than 10 minutes. But
who wants to see a demo? I'm
yes,
sure
we want to see.
Right?
Yes, all of us want to see it.
Yes.
Yeah.
So I'm going to move over here. This screen is basically logging into a website. It's a test website on web authentication. Notice I've registered. If you go to security settings, just like any account page on any service, a bank or a social media site, they have a security settings page. And in this new option, we can add an internal authenticator. And notice now this is a basic call we call register command in web authentication. And depending on what the platform has, it calls up the relative native APIs. And in this case, it's my Windows 10 machine, which has a fingerprint. I log in with my fingerprint on my Windows 10 machine. It says here, you are adding a Windows computer as your authenticator. And I'm logged in. So that's how simple it is. Users are used to using things they have built in. I'm showing another example here, which is really nice. I have on my phone here, logging into the same site on my web, on my phone, which is an Android. When I log in, notice these are the system APIs for Android. I didn't build this. This is part of shipping Chrome devices. It says I've got 3 ways to authenticate myself. It sees that my site requires me to do an external authenticator to log in. I'm going to choose, I can choose NFC, which is part of specs, Bluetooth, or USB. The Android has a USB-C as well. So I'm going to log in to my site. And notice that I can see that I've logged in with the external authenticator over an NFC. And notice there was a Windows computer there, that I just lit it on my computer. And I said, you know what, I don't really want to use my computer for today. I want to add my WebAuthn credential on my phone so that I can log into my phone now. I can keep my very secure bootstrap device, my backup device, away now. I add an authenticator. Notice it pops up the system APIs. This is from, again, shipping with Android. A login, fingerprint, added. It's going to take me to the page again. And it's going to say, is logging, is your Android phone, is your authenticator, I'm done. And notice now I have 2 internal authenticators. That's WebAuthn at scale. I mean, this is remarkable. This is what we've been working for a very long time. This is from Google. That is from Microsoft. So that's how the standard can work when you implement things and the standard sets the baseline. Obviously, my external authenticator can traverse different devices, but I'll show you on a day-to-day basis, if I log in again to my phone, I don't need to use the external authenticator since I bootstrapped it on my phone. Now my phone as an authenticator, I can log in straight with my phone to the service. Single gesture, right? You didn't see me type, anybody saw me type codes? So that's what we're really excited about. Happy to take some questions.
Sure, thanks. Much of public key infrastructure that you were talking about earlier to ensure that you're not going to the wrong site relies on DNS. And a lot of web filtering services rely on hacking DNS. How does this infrastructure, the FIDO and WebAuthn infrastructure, work to make me feel better about authenticating with the right site?
Yes. So the premise of web authentication does rely on TLS. It does rely on DNS. I think the conversations is about where are the gaps in those areas that we need to close out. There are areas that obviously, we're TLS 1.2, so I mean, we've made improvements in that protocol. DNS, there are challenges, but in general, I think just because one element has not the perfect place, we can't just throw everything out the door. So I think DNS attacks are real, but I would still say they are scoped to very sort of targeted attacks that only people with a lot of resources can do. No technology is fail safe, right? And so when we talk about web authentication, now we have a new level playing ground, right? So I would encourage you not to think that WebAuthn solves everything. I don't claim that it does, but it changes the game on the minimum bar to attack a user, right? So if the minimum bar is just call up a carrier and says, you know, this is my old phone, this is my new phone, that's not a really high bar. So I think web authentication steps it up, which means that attackers need to throw more resources in. And every time you throw more resources in, it's more expensive. So we want to make it more expensive for these attacks to happen so that, honestly, the money is on them, not on your fraud money. So I think we believe that we are only at level 1, right? So there are many new things that we are trying to incorporate, things like IoT and things like that, into how things can work in a more automated fashion. So, but the underlying foundation is there, which I believe is a very critical element for us as an industry to think about. We should think about, even if you couldn't move away from passwords today, what is your path today now that the foundation's laid?
Mark.
So I think, you know, WebAuthn protocol, great, but how do you deal with sort of the inconsistencies in the platform providers and sort of the insecurity of platforms? Because I, you know, read about the S10 and the ultrasonic fingerprint was hacked in 13 minutes, right? And so, you know, if I'm a provider and I'm integrated with Authn, and then, you know, my consumer is using platform level security that isn't all that great, like, you know, how's that good, right?
It's true. So to some element, there are two basic principles of how we evolve in the specs, right? So there's a lot of things built into the operating systems today, right? So just to take away the device manufacturer first. First element is that this element that you need to think about what the operating system is there. There's no other method at scale that we can affect global user communities if it's not on the operating system. So will there be issues on the operating system? Absolutely. And I think that, but that doesn't preclude us from a new bar. Just the same argument, right? The second thing about the S10 or Samsung or whatever. Now, at the end of the day, every device manufacturer will come up with their own scheme for how they believe is protecting their devices. The big thing that I didn't really cover was that everything that you use an authenticator is a choice of both the user as well as the service. You can, in the protocol, restrict what type of authenticator, okay? So if you do your due diligence and you say, you know what, I recommend Yubico YubiKeys today, but they have something happen, I don't recommend them, it's your choice. Your platform service can decide that they are no longer available or available. You can say, well, Google made a mess on this particular pixel, I will not allow it to be an authenticator. Those are all choices that the services can do today. I think what we're seeing today is that there are some people will get it wrong, but most people want to get it right? So I think this is level 1 in the specs. So what we want to see happen is that innovation and sort of like the people that build things should know how to build things so that when they're actually using by people at scale, they will fix all these things. I won't say everything's perfect, but again, if we didn't have, just think for a moment, if we didn't have web authentication standard, what is going to happen? We're going to have more fragmentation, not less, more. And we're already fragmented. We don't need, sure, me saying it, every bank creating their own thing. I mean, I'm a user of 3 banks. If every bank says I got to buy a new phone for my own thing, it's like not good. And every bank has to create their own devices, not good, right? And on top of that, I don't just want to use it with my banking side. I want to use it with my cryptocurrency side, my email side, my social media side. If we don't think of a standardized way to do that, like, we will be typing a lot of numbers. So we don't want to do that. So the foundation is laid. I would say that there's a lot of work to be done. We're doing a heavy investment in level 2 right now on the spec. We take into some additional considerations from what we call the relying parties, which is services. A number of financial institutions are involved now in level 2, which is some of the other requirements coming in, which is nice. So I think the conversation has just started. It's not the end. And I think we have many good things to do.
Okay, any more questions? Okay, Ben, the last one.
Yeah, so prioritize convenience over security every day, right? There'll be a data breach, and they'll think about security for like 3 days, and then they'll go right back to convenience.
Yes.
So how do you kind of think about kind of your process within that? How do you make it, that convenient experience, as much as possible, so that they'll actually adopt this?
Absolutely. So if you notice in my demo, did I type anything? Just for a moment, did I type anything? I did not. So the way to get to users at the end of the day is frictionless security, right? Anything that you ask the user to type is going to be, not just get it wrong, but it's just going to be friction. So web authentication has all the foundation to create the best user journey for your users. And it's not just about getting to the front door one time and you're in. Every backup option that you see me enter will have the same premise, which means that you can get the same level of assurance as a bank or a financial institution with the same level of usability. When we built, I think one of the questions Rachel asked me was like, what is the thing that you want the industry to know? I want the industry to know that pitching security and usability against each other is the wrong way to go. We need to build technology for people which is easy and secure, not the other way around. So WebAuthn, we spend an enormous amount of time to solve usability problems and actually, frankly, privacy issues as well, privacy problems. So privacy, security, usability, they all, to us, mean something in the standards world, and we take that seriously. So nobody wants to implement a security system, and nobody's using it. That's not the goal. So everything that we think about for usability is single gesture, part of who you are, what you do every day. If you're going to use Touch ID to log in your phone, then you can use Touch ID to authenticate. But the authentication better be standardized, otherwise we've got this one-off situation going on.
So with that, thank you, Jerrod. Thank you for an interesting demo. Thank you. Yeah.